I welcome you all for this presentation. In this presentation, we are going to discuss about layered network architecture. This is the overview of this presentation. First, we are going to discuss about communication architecture. Then what is the need for layered architecture? Then layered tasks. Then the very famous ISO-OSI model. Then 7 layers of the ISO-OSI model. Then functions of each and every layer. Internet protocols versus the OSI model, followed by summary of this presentation. What is communication architecture? This communication architecture is a strategy for connecting the host computers and other communicating equipment. Generally, in computer networks, why we are having computer networks or learning computer networks means in order to provide efficient data communication. So we need to understand what is the architecture behind this data communication. And this architecture defines the necessary elements for data communication between devices. Here we are communicating between the devices. So what are the elements needed for data communication that must be defined in the computer communication architecture. And the communication architecture defines a standard for the communicating hosts. Standards mean some agreed upon rules must be defined for each and every architecture. And the programmer formats data in a manner defined by the communication architecture and passes it on to the communication software. That is, separating communication functions adds flexibility. Say for example, we do not need to modify the entire host software to include more communication devices. So in the layered architecture, the layered architecture is providing more and more flexibility. Say for example, if you want to change any particular functionality of in any layer, then it can be easily changed. Not necessarily have to change the full architecture. In one part alone, we can make the changes. That is about the communication architecture. Next, what is the need for layered architecture? Main advantage of layered architecture is it simplifies the network design and it is easy to debug network applications in a layered architecture network. And the network management is easier due to the layered architecture, and the network layers follow a set of rules called protocol. Because one of the component in the data communication is the protocol. We already seen in the last presentation. That is, we need 5 components for data communication. One is the sender, then receiver, then message, then protocol, as well as the communication medium or link. So we have to follow the protocol. Both the sender as well as receiver have to follow the same set of rules. Then only the communication is in an effective manner. The protocol defines the format of the data being exchanged and the control and timing for the handshake between layers. Generally, before going into discussing the ISO-OSI model, we are discussing a general or simple layered model we are following in day-to-day life. That is, say for example, two friends are communicating through postal mail. So how we are communicating through postal mail? Nowadays, we are not communicating through postal mail. Mostly, official documents are only coming through postal mail. But earlier days, we had that mode of communication only. So if we want to communicate between friends, earlier we used to write a letter. So while for writing a letter, see here, the sender needs to do some activity to post the or send a letter to the friend, that is the receiver. So first the sender has to write a letter. After writing the letter, before that he or she has to buy a letter, then write a letter, then put it in an envelope and drop in a mailbox. And the letter is carried from the mailbox to the post office. So first task is sender is doing some activity that is in the higher layer. See here it is in the higher layer. Then next what the sender is doing is just putting the letter in the mailbox. But from the mailbox the letter has to be carried to the post office and the letter is delivered to a carrier by the post office. So this is the lower layer. After the letter received in the post office, the parcel is carried from source to the destination. And in the destination, what happens? Because if you are sending a letter, we are in one state, we are sending a letter to another state, the friend is staying in another state. So what happened? One general main head post office is there. They just see the pin code and they send the letter to the concerned state or the head post office or main post office in that particular area. How the post is travel from this state to that state through air or through train or through bus, many ways of communication is there. So this communication link, you see, the parcel is carried from the source to destination. This is that is the letter is parceled and it is carried to the next post office, that is the receiver's post office, through some transmission medium. Here the transmission media is some a train or bus or some aeroplane, like that only. And the letter is delivered from the carrier to the post office. Then the letter is carried from the post office to the mailbox. And from the mailbox of the receiver, the letter is picked up, removed from the envelope and read. So here you see, first the sender has to follow all levels: higher layer, middle layer and lower layer. Then it is passing to the communication media. Then again the same set of work is in reverse form, it is followed: lower layer, middle layer and higher layer. So here from this what we understand, all the upper layers are taking the services of the below layers. So the sender is putting a letter, but they are taking the service or getting the service of this middle layer, and the middle layer is getting the service of the lower layer. Likewise, each and every layer is getting the service of the next layer. The same way only we are following in the ISO-OSI model also. So before that, you need to know what is ISO-OSI model. ISO means it is an International Standards Organization and OSI stands for Open Systems Interconnection Model. Why Open Systems Interconnection means there we can follow, any protocols can be followed in each and every layer. So Open Systems Interconnection Model. And this ISO-OSI model that is established in 1947, the International Standards Organization is a multinational body dedicated to worldwide agreement on international standards. An ISO standard that covers all aspects of network communications is the Open Systems Interconnection Model, and it was introduced in 1970s. So in the 1970s, everyone talked about this model only, and this is the very famous model, and everyone felt that this is the best model, like that. But in 1990s, the TCP/IP model was tested for internet. So the TCP/IP model is prevailing, and that is only we are using in all activities. But this ISO-OSI model is not implemented fully. It is a model, but it is not implemented fully. It is not tested fully. So the TCP/IP model was tested fully and it works in the internet. So that model is a very famous model, but the base for that model is ISO-OSI model. So only we are learning this ISO-OSI model. So here the ISO is an organization and OSI is a model. So always don't confuse with, because ISO, their reverse OSI is there. So ISO is International Standards Organization and OSI is Open Systems Interconnection. So actually ISO is International Organization for Standards. Actual expansion is. So you need to know what is the difference between an organization as well as a model. And it is specified in this ISO-OSI model is specified in ISO 7498. So it is a standard, like standard model. So only for any standard model, there may be some numbering. Say for example, you are having a unique identity number. Each and everyone is having a roll number. So same number is not given to one number is not given to two person or more than one person. Each and everyone is having a unique number. Likewise, Each and every model is having in standards, each and every model is having their own unique number. So ISO 7498 means it is for ISO-OSI model, and this model has 7 layers. So these are the 7 layers of the OSI model. The first layer is the physical layer, then data link layer, then network layer, then transport layer, session layer, presentation layer, and application layer. So based on the application, we can choose some of the layers also. Not all layers are necessary. Say for example, if two devices are connected point-to-point link, in such case, the network layer, no need to implement the networking. Network layer, no need to incorporate in the architecture, because directly point-to-point link, dedicated connection is there. So in such case, the network layer is not necessary. Likewise, some of the layers are not necessary for some applications, for some working principle, and but the basic layers, the application layer, and then the data link layer, physical link layer, all those things are those layers are must, but in between some layers are not needed for all the working of the network. That later on we can see. So this is the interaction between layers in the OSI model. Here you see we are having 7 layers, and the last 3 layers, that is physical, data link and network layer, are the network related layers. These are network related layers, and the top 3 layers are the user related layers. Application, presentation and session are the user related layers. And this transport, it only provides end-to-end delivery or process to process delivery it is giving. So here you can see the physical, data link and network. These 3 layers are only connected to each and every devices. But the session, the top layers you see, session, presentation, application and transport, they are connected from the sender as well as the receiver alone, not the intermediate nodes. Intermediate nodes are connected. Peer-to-peer protocol is followed in the application, presentation and session and transport. But in network, data link and physical only, all the intermediate nodes are also connected. Intermediate nodes in the sense some routers, switches, many things are there. From say A to B, we are sending something means intermediately many nodes are there. Those are also connected. So they are calling us network interface layers, and the top layers we are calling as user interface layers. In between we are having the transport layer that only sends the segment from the sender to the receiver. That is a process to process it sent. So in detail we will be discussing in the coming slides or some coming presentations. And one more thing, if you are exchanging the data from the sender to the receiver, what happens means, what is the last layer, that is the higher level, is the application layer. So the application layer is having some data because the sender is having some data to send. The sender, what the sender do is, with the data, the sender will append the header. In the header detail only, who is the, what is the source, what is the destination, all those details are available in the header only. So the data plus header, that only forms a packet. So the data and header are passed to the next layer, that is the presentation layer. So here this application layer is getting the service of the presentation layer. So in this presentation layer, the presentation layer will treat D7, H7 as data. D7 is the data, actual data, and H7 is the header of that particular layer. But H7, D7 is just passed to the presentation layer. In the presentation layer don't know H7 is there, D7 separately there is there. The presentation layer don't know that. It just accepts it as a single packet only. Then the presentation layer append the presentation layer's header H6. Then the H6 and D6 are passed down there. The session layer don't know that what is the header of the presentation layer and all. It as such collected that as a data and it appends the header. Likewise, it goes on. But in the data link layer, in addition to the header, trailer is also added. Trial, what is the purpose of having trailer here? Means in order to provide error control, trailer is provided. Then in the physical layer, everything is converted to bits, and this bits is passed on to the transmission medium. Then it goes to the receiver, and in the receiver, in the physical layer, the bits are converted to frames. The data link layer, we are calling it as frames. Here bits, the physical layer, it is bits. Then in the data link layer, they are called as frames. Then in the network layer, we are calling it as packets. And here we are calling it as segments. And these segments are passed. Okay, this way only we are treating it, the data here. Then this bits are passed to the physical layer of the receiver. There it is, here everything is encapsulated. The data as header are encapsulated and come down. Then again and again all the headers of each and every layer are encapsulated. Then they are opened up and the corresponding data is taken. So from this physical layer bits, it goes to the data link layer. At that time, it is open up. What is the header as well as what is the trailer? Then this data is passed here. Then there also it is open up as D3 and H3. Then it is open up. Then H4 and D4. Then H5 and D5. Then in the presentation layer H6 and D6, and in the application layer H7 and D7. Finally, it is in the H7 only the destination address is there. So the receiver knows this is the data. D7 is the data. Likewise, the information or the data is passed from sender to the receiver. The functions of each and every layers are, this is the gist in detail. In the coming presentations, we will be discussing in detail about each and every layer. First is the physical layer. It transmits individual bits from one node to another node over a physical medium. And the data link layer is responsible for reliable transfer of data frames from one node to another connected by the physical layer. Here it is a frames. Here individual bits. Here transfer of data frames. The network layer manages the delivery of individual data packets from source to destination through appropriate addressing and routing. And transport layer, it is responsible for delivery of the entire message. The difference is there. In network layer, it just delivers the packets from one node to another node. But in the transport layer, it delivers the entire message. That is the difference. The entire message, that is process to process delivery, happens in transport layer, or end to end delivery happens in the transport layer. That is, it is just delivering the entire message from the source host to the destination host. And the session layer establishes sessions between users and offers services like dialog control and synchronization. And in the presentation layer, it monitors syntax and semantics of transmitted information through translation, compression and encryption. And in application layer, it provides high level application programming interface to the users. So these are the functionalities of each and every layer. So we are having totally 7 layers, and each and every layer is having different functionality. And the first layer is the physical layer. They are bits, data link layer frames, network layer packets, transport layer entire message or segments. Then session layer, it is mainly for dialog control and synchronization. Then presentation layer, it just gives the syntax and semantics of the information transmitted, and the application layer is providing the high level application programming interface. So see, this is the gist. That is, in the physical layer is the first layer. It transmits bits over a medium to provide mechanical and electrical specifications. That is how the signal is passed through the transmission medium. That is the physical layer. In the data link layer, to organize bits into frames to provide hop-to-hop delivery, and in the network to move packets from source to destination to provide inter-networking, and transport layer to provide reliable process to process message delivery and error recovery. session to establish, manage and terminate sessions, presentation to translate, encrypt and compress data, and application to allow access to network resources. So totally 7 layers, the functionality of all the layers and the numbering of the layers. Then there I already told you there is a difference between the ISO-OSI model as well as the internet protocols. So here you see all these 7 layers, but now we are not having all these 7 layers. In the physical layer we are calling it as a hardware layer, and in the data link layer we are calling it as a network interface, and the transport and network we are calling as TCP and IP. Then we are having the application. Application, presentation and session are merged into application, and transport and network TCP IP, then data link network interface we are calling it, then physical is the hardware. That is, explicit presentation and session layers are missing in the internet protocols, and data link and network layers are redesigned somewhat. So here you see network, part of the network, and the data link it is given as network interface, so it is redesigned somewhat. Other than that, session, presentation and application, everything is merged and it is given as application. And you already know in physical we are just transmitting the bits, then data link it is frames, network it is packets, transport it is segment. Above all we are not telling anything, so it is a application. So in this presentation we discussed about the communication architecture, need for layered architecture, then layered task, then the ISO-OSI model, then 7 layers in ISO-OSI model and functions of each and every layers, and what is the difference between internet protocols and the ISO-OSI model. In the next presentation we will be discussing about in detail about all the 7 layers of ISO-OSI model. Thank you.